Welcome to today's webinar. We are going to be talking about the hydrology tools inside of RoadEng. So this is going to include today both hydrology tools inside of the terrain module and a very exciting version 12 update. We also have the hydrology tools now inside of location. For those of you who don't know me, I'm Erin. I'm the operations director here at Softtree, and I get to lead most of our webinars in terms of being a host. And with me is also Matthew Dickey, our training manager. He's going to be doing all the heavy lifting in today's webinar. For a bit of an agenda, we are going to start with me, little introduction to the different hydrology tools that we have available. Then we're going to head into the terrain module, explore how those tools work in a little bit more detail. Come back to me for a quick intro for hydrology tools in location, and then we'll head into the location module to explore examples there as well. A couple housekeeping notes. First and foremost, you are all muted. So if you're here in the live webinar with us, you won't be able to ask a question out loud, but you can type one at any time using the Q&A section of your GoToWebinar panel. And this webinar, like all of our webinars, they get recorded and then they get posted to YouTube. So if you're watching this off of YouTube in the future, feel free to give it a like, type your questions there. We do tackle them as well. Okay, let's get into it. So I'm going to start off with a quick introduction to the 5 different tools available in our hydrology toolset inside of terrain. So our hydrology tools really can help you to understand any of the sort of considerations associated with drainage, obviously very important in any type of civil engineering project that you're going to do. So these tools have 5 functions. First and foremost, we've got watersheds, then drainage area, streams and ponds, flow paths, and although not really a tool like the other ones, we have hydro enforcement. So this is a feature property that you can enable. It's going to allow flow through an actual feature. Let's take a quick look at each of them. Once I mentioned, I forget the order of my slides here, mention that these are some of the tools that are available in the location module. So as I mentioned, new in version 12, you've got some of these tools. You can run them as you design, see the impact of drainage on that new designed surface and start to make better, more educated engineering choices. So we're going to explore that in sort of the second half of the webinar. To start, let's talk about hydrology and terrain. And hydrology and terrain really starts by understanding that all of these tools, unlike pretty much everything else that we do, are actually going to be run on a grid surface. So here on the screen, you've got your tin model. That's the surface that we usually work with. That's what we get volumes off of. That's what we design with. That's not how we consider hydrology tools. So hydrology tools are based off of a raster grid. So a slightly different approach. We're not looking at triangles. We are looking at a grid of rectangular cells. Each and every one of the tools that we're going to talk about today has an input for cell size. So this is kind of what we're talking about when we talk about cell size. You've got here on the left a 1 meter grid and in the center a 10 meter grid. So obviously very, very different levels of detail and very different computation times. So it's something for you to consider as you're running these tools. Obviously, smaller cell size, you're going to get much more detail and accuracy in what it's calculating. Okay, that's my quick intro to that. So let's talk about each of the tools. Watersheds, this was actually the very first hydrology tool we introduced. This was back in version 10 when it first came out. In 11, we did do a complete overhaul of the algorithms. This one's faster, a lot more accurate. And watersheds really is it's pretty obvious tool. It helps you create those independent catchment areas on your tin surface. So trying to figure out where the watersheds are, and this tool does that for you. The next one that we're going to explore today is drainage area. So this can be drainage area to a selected point. So you can select an individual point, for example, a culvert location, or you could select a feature and be able to calculate the drainage area to that feature or point. It also allows you to calculate the most hydraulically remote path as well as the centroid. So getting some of your inputs that you're going to need to put into some of your culvert sizing algorithms. The next tool, or I should say the third tool, streams and ponds, and this is the one that you probably see us talk about the most. We use it all the time when we're talking about Path Explorer and construction zones and wanting to minimize crossings. This is the tool that's going to generate for us the location of all the streams potentially on our topo surface, as well as ponding areas. So a very key, and I should have put a bullet note on this, but a very key input that you're going to want to pay attention to is your stream drainage area. So when Matt gets into the software and shows you the dialogue, stream drainage area is the total land area where precipitation, whether it be rain or snow, is going to collect and flow downhill to form that particular stream. So if you have a larger minimum drainage area, you're going to have less streams that are going to show up from the calculations. If you have a smaller minimum drainage area, you're going to have more streams that are going to start lower in the watershed. So really depending on, the area you're working and what you need, knowing that you need to control that minimum drainage area, large numbers, less streams, small numbers, more streams. Okay. Next, as I complete my quick introduction to each of the tools, is flow paths. So flow paths just basically calculate all the flow paths from either a feature, as you can see on the left side where we've brought a road back into terrain, or from selected points. And so yeah, really useful tool that you can use both on features and points. And lastly, the one that probably needs the most introduction is hydro enforcement. So this one is not an actual tool. You're not going to go to the hydrology toolbar and press hydro enforcement. This is actually something you're going to set in the feature properties panel. So the best example of a type of feature you'd want to include as a hydro enforced feature is something like a culvert. Basically, that means that when it's hydro enforced, when we look at it from a hydrology standpoint, flow goes through it. So it's really, really, useful for helping to add that realism to how water moves in your model. So all of the hydrology tools that I mentioned before support hydro enforcement. So if they come across a hydro enforced feature, they are going to honor it. And this really makes it easy to account for, as I mentioned, flow through culverts or road embankments, or even to account for pumping stations. So if you've got a situation where you're pumping water upslope, being before it's discharged back into the topo, a hydro enforced feature can allow you to do that. Okay, enough about my morning intro. I'm going to pass it over to Matt now. We are going to head into the software. I'm going to turn my camera off, so I'll see you all again at the end of the webinar. And Matt, over to you.
All right, perfect. So we've just opened up terrain, and a lot of these hydrology tools are stuff that we typically use in passing. But we'll spend a little bit more time unpacking things. So to start here, I'm going to just bring in my topo data, as we usually would. We'll model our surface. And I'm going to spend most of my talk in the 3D view here. So if we just look at that topo surface, we can probably just have a pretty good idea of where the streams are if we look at it. But if we want to actually calculate hydrology features, well, we're going to come up to the top ribbon here. And I'm going to start by introducing streams and ponds. And well, you don't have to do it in that order, but streams and ponds is going to add a lot of context here. So I'll click this guy here. I'm going to just leave our default settings. We'll let this chug away. And there we are. We have a bunch of lines for our streams, and we'll look at it in the plan view, and a bunch of polygons for our ponding areas. Now, with that, if we kind of zoom in here, we can begin to kind of unpack what we're dealing with in terms of those variables. So we'll kind of go through this line by line. As Aaron introduced, we have our cell size. So the software is not looking at the tin surface as a series of triangles. It's looking at a rectangular grid. And well, with that, we can see that our streamlines, let's just pick anywhere here. have kind of these bends that are either on 90 degrees or 45 degrees. So it's not looking at the same geometry as the triangles. Instead, we're approximating it. Now, with that, the smaller the number we have here, the better it's going to approximate the surface, but there's a kind of point of diminishing returns. And then the other side of it is, well, if we had a 2-meter grid and I ran a 2-meter grid on the data that we brought in, and in this case I did, well, I'm not really going to get any improvements out of having a 1-meter cell size. So we can get a faster calculation time if we run with that. We can click that and we'll just note that, okay, that went quite a bit quicker than last time just by running with what we had there. Now it does change the surface that it's seeing. And then other elements here, well, we've got our ponds, and some of these might be actual ponds. This one we're almost a hectare, but a lot of these are quite small. And if these little guys here are something that we just don't want to worry about, well, we can kind of limit how much we're seeing just by increasing the minimum pond area. So we can bump that up to 500 and away we go. And then the other kind of big important parameter here is the drainage area. So right now I just ran with the default settings. I've got my stream drainage area at 7,500 square meters. And right now that stream is starting fairly high in the watershed. And if I were to look at my topography and say, well, I'm being generous with what's considered a stream. If we wanted to start those lower in the watershed, get fewer streams, well, we can bump that number up. And I'll go with 2 hectares here. So with that, it's not necessarily that there's a right or wrong number. When flow becomes channelized, it's going to depend on, well, climate and geology, etc. But there usually is kind of a sweet spot for a given region on what's an appropriate number. And then the other side of it, it's also a little subjective. If you want to be generous and calculate, say, those kind of seepages and non-defined channels, you can go with a smaller number. If you want to only capture stuff that's actually quite channelized and well-defined, then you can go with a bigger number there as well. So we've got a lot of the elements tackled here. But then another one that can be a little bit of a source for confusion is depression fill depth. And now I'm going to, again, just kind of make my life easier. So we can see those ponds as, well, actually filled in surfaces on our topo. I'm going to just make them appear as faceted features. So I'm going to turn that on. I'm going to turn that on. So I've just selected all my stream pond features and I've made them 3D facets. So those are surfaces that are separate from the topo. And with that, hopefully I make it a little easier to see what we have going on. So let's come up here. And we can see at this location, we've got a stream coming down the channel, and it comes through here and it stops. And then in other spots, we can see, we'll come back down here. Well, this location, we've got a stream that comes down the channel. It has a ponding area and it flows to the outside of it. So what this parameter is doing is it's allowing us to fill in depressions up to a certain elevation and allow flow to come up to that level. And if it reaches out less than that level before there's an outlet, it'll flow on the outside of it. So what does that look like if we were to say, well, I don't want to fill in any of the depressions whatsoever? well, we get something that is probably not what we want. So I just ran that. And we can come around here and we see that we've got, well, something like this where the stream goes, it's calculated, and then it just stops. And that is because there's a little bit of a increase in elevation on that next cell, and there isn't that kind of tolerance built in to allow that flow to run through. So of course, we'll probably want to bump that up a little bit more. So we'll go 0.2. We can see we're getting better. Still have streams terminating before where we'd actually like. So yeah, we can play with that number and find something that works well. And in all these cases, at least our intent is to have defaults that are generally pretty appropriate in most cases. So and again, just to, actually I'll leave my streams as not facet features for now. And we can, well, have that depression fill depth to help us allow flow to move beyond these little surface imperfections. And it's kind of nice to deal with things that are surface imperfections rather than something that's significantly different. And if we go back to this guy here, well, we can see that there's a road prism on that surface. And here I imagine that that's not going to pond. I imagine that there's probably a culvert there. So if we wanted to introduce the concept of culverts and allowing water to flow through our surface, so far all the software is looking at is the topo surface and flow from one cell to the steepest downslope cell adjacent to it. So we're going to add in a feature that is, and we'll call it culvert, and we're going to make it hydrone forest. So we're going to come in here, we're going to zoom in, we're going to set the start of that feature there, and we're going to set the end of that feature there. We'll also zoom in here so we can see what it is that we're actually looking at in the plan view. So right now that pond fills up to a meter depth, doesn't reach the outlet to flow around the outside, but since we've added this hydro enforcement feature, we should see water is now not showing as being ponding back there. It's flowing through and away we go. So, and of course, a lot of the time you're going to draw those hydro enforcement features from the inlet side to the outlet side, or if you had them surveyed, you could just bring them in as your surveyed information or line work from GIS database, what have you. Now, if it is a case where you don't want to just allow that water to go from the high side to the low side, hydro enforcement features do support that as well. So we'll go up here to another location on our surface, and we've got a gravel pit. And, well, it may fill up with water, or maybe they have a pump, and we wanted to show that water being emptied. So again, we'll draw that feature, and we'll go from here, and well, where do we want this to go? So we can go upslope with this. We'll put it right there. We'll assume that's the outlet. And we'll recalculate those features. Oops. And of course, if you're using a hydro enforcement feature, you do want to set the property. And there we are. So we've got that water being pumped out of our hole to where we actually plan to discharge it, regardless of elevation. Now let's kind of come back to that other hydro enforcement feature that we added in. And where was it? There we are. So this feature, of course, if it's a culvert, one thing that we're often going to be interested in is the drainage area. So we're going to move on from streams and ponds. All these concepts of depression fill depths, hydro enforcement features, they're still relevant, but let's look what we get for outputs from these other tools. So drainage area, I'm going to use typically the same settings across these different tools so they're consistent for what we see. And well, to start, I'm just going to use my current point. So it's not looking at the feature. I could calculate this to a feature if I want, but we can hit OK and away we go. So what have we done here? Well, we've calculated our drainage area. And here we can see a spot where, well, we weren't quite generous enough with our fill depression depth. So here, and there's not actually a depression, but it comes down to the fact that we've got a cell size that's large and we're losing out on that granularity. So let's bump this up so that water flows through. We could also add a hydro enforcement feature if we wanted. There we are. And we'll come back here to rerun that calculation. So drainage area, I'm going to run this guy. And there we are. Since we've got the little imperfections in the surface accounted for, we can see our drainage area for this feature. Now we can see the area, and it's going to be a default status that's populated over here in the properties panel. So I'm looking at 664.2 hectares. Aside from just the drainage area, we're also calculating a centroid point. So if we're interested in where the centroid of this polygon is, we could search for it and find it. And then a little more interestingly, we have the most hydraulically remote path. So this guy here, that most hydraulically remote path, we can see it goes from that point that we've calculated. It extends all the way up to the back end of our drainage area. And there we are. We can see the length. If we were interested in seeing more information related to that, we could add more attributes to report here as well. So in the geometry tab, if I was interested in my average grade of the feature, we could add that in, and I can see that it's running at about 10% to get from the back end to where we'd like to be. Now, another kind of note or element to, I guess, acknowledge here is, well, it's a surface calculation. And it's only going to consider the extent of the surface that you've given it. So here, if I look at this, okay, we're doing pretty good, but it does get lopped off because we've reached the edge of our tin. So it's something that if you're using it and you want to, well, rely on things like area calculations, be cognizant that it's not going to interpolate beyond the surface that you've given it. Now, another aspect of things, or another tool, and just so we've got drainage area, we're calculating drainage area to a point or to a feature if we used features instead. A lot of these parameters are the same. I'm going to introduce drain radius with something else here in a moment, but let's move on to flow paths. So if instead of being interested in where the flow contributes upstream of our point, if we were interested in a pour point where the water goes from a given location, we could calculate that. So we could do that just at the outlet, but here we're in a stream, so it's not that interesting. If instead we were interested in, I don't know, maybe adding a culvert in at this location, and if we add that culvert in, is it just going to run adjacent to a road? Is there enough relief to get it off to the stream on the other side? So for that, we could add in a feature. So I can say, well, that might be my outlet there. And that's where we're at here. Let's run the flow path from this guy and we'll hit OK. So here we could see, well, if we did put a culvert outlet, it is going to flow through this little depression and get down to where we'd expect it to be. We can follow that all the way down to it falls off our surface. Now I'm going to just remove my drainage area features, most hydraulically remote flow paths, my flow paths themselves, and let's add in a feature that represents my road center line. So the existing road center line, I should say. And as we get into location, we'll deal more with the designed or proposed road geometry. I'm just going to take this guy here. I'm going to click Insert. I have a shape file in this case. We'll run this guy here. We'll bump this guy up a little bit so it's a little easier to see what we have at play. And this works for both drainage area or flow paths, but we can do this analysis not just to a single point, but relative to a feature or features. So in this case, and just for the sake of showing something a little different here, well, we can take that feature. We're going to run our flow paths on it. I'm going to select it from the list. So we're not just going to use that flow from current point only. We're going to turn that guy off, turn this guy on, and select our existing road. Now, another parameter that was in drainage area is the drain radius. So here in the lens that I'm going to look at this is, well, what if I wasn't just interested in flow from a single point or even flow from the line? I wanted to consider maybe I was worried about if I had a vehicle driving along this carrying a dangerous substance, where that might flow if it were to spill. So I'm going to say I'm going to consider it 10 meters either side of our feature. So we've got a drain radius of 10. And we'll hit OK. And there we see a bunch of lines. So these bunch of lines kind of represent, well, if we go out 10 meters either side from this feature and say a truck spilt, well, if it's spilt there, the substance may go downstream on that path. If we come up here, we can see that, well, it's going to spill there and run down there. But aside from just telling us where it's going to go, it's kind of useful to know where we're probably not going to have to worry about it. And even though it may be downslope, it may not be kind of in line with the flow path. So here, a lot of our flow is going to be along the edge of the road, and we don't have to worry so much about right here. Just preface that with, it is just a surface calculation. We're not considering any subsurface flow or seepages, etc. But yeah, we've got our flow path calculations. And once again, I'm going to just remove these from what we're looking at. I'm going to keep the streams. I find they add context. The last tool that we're going to introduce here is the watersheds. Actually here, just again, make it a little less cluttered, a little clearer that those ponds are in fact ponds when we're looking at the 3D view. Just going to select similar, and I clicked the wrong button. We're going to make those 3D facets, so there we are. Now the other tool is watersheds. So watersheds is really similar to, well, the drainage area calculations, but instead of looking at flow to a single point or a single feature, we're going to calculate flow to where it either falls off the surface, or if it flows to a point where it doesn't actually escape the surface. We're going to click this here. We're going to use all of our same settings. And there we are. We can see we've got, well, those watersheds delineated. So, and if we look at this big green one, it comes down here and dumps out. And that's the same one that we were kind of focusing on with the culvert example. But if we go, and we'll go up towards the top here, if we have something like this, which is kind of interesting, well, that is a lot deeper than a meter. So flow in this location comes down here, but it can't escape and it just terminates. So we can have watersheds isolated in a surface. Now this tool is kind of more beneficial from kind of a high level. Okay, where's my water going to go? A lot of the time on really dramatic landscapes, it's fairly obvious, but it has more utility on the flatter terrain. So I'm just going to switch over to a kind of much flatter example here. So here we've got a pretty benign topography. And if I wanted to get to that location, well, it's probably going to be pretty unremarkable if we're focusing on slope. But if we use the watershed tool here, we can see that we're actually pretty close to the height of land here. And maybe instead of just coming perpendicular off the existing road, we could come off the height of land and not have to worry about concentrating flows or intercepting flows as much as we would if we were dealing with somewhere else. And for this, it might be worth introducing the fact that we can also, of course, exaggerate our vertical exaggeration in the 3D view. So that's where we were looking at here. So we can see, oh yeah, that's the split. And then if we wanted to, we can drape that plan view here as well. So with that, I think I'm done introducing concepts in terrain, and I'll pass it back to Erin before we dive into location.
Awesome. Okay, let me get my screen resharing here. Okay, hopefully we're back up and running with the screen there. So in version 12, which is now actually out in beta testing, we have added hydrology tools into the location module. So there's, I should say, the three key tools: streams and ponds, drainage area, as well as flow paths, can now be accessed through the hydrology button in the corridor ribbon tab of version 12, which is super cool because now you're going to be able to run those tools on the design surface. So in what Matt was just showing you, we were working off of the topo surface, and then he brought in that one instance, exported from location that road, but now you can actually do it live on your design. So you can see the impact, understand where you're redirecting flow, where you're intercepting it, and how is it traveling on your road surface. So here in location, as I mentioned, we're going to be able to understand the impacts of our road or our infrastructure project on natural drainage. We can see, run that streams and ponds tool, see what's happening to those natural drainage paths. As well, for those of you who have an interest in culverts, which is pretty much all of you, you can include the drainage area now, flow length, flow slope percentages inside of your culvert data table, making it a heck of a lot easier in order to go and run those calculations for size. So we're going to head now into version 12 location module, but first, maybe a little bit of a reminder, why have we done this? What is the importance of it? And of course, this should go without saying, but obviously managing water and the design of the road, there are a lot of hazards and a lot of negative outcomes that can result if you don't manage water properly. Outside of those really dramatic impacts, there's also impacts that can happen to the landscape. And I am sorry if you've seen this slide before, I happen to love it. Here we've got a road acting as an earthen dam, and you can really see the impact of not handling drainage properly and the impact and to the damage to the landscape with the contrasting growth rates on either side of the road. And then finally, in terms of sort of the impact when we don't manage water properly, we can have damage to the road itself, you know, potholes, scouring. So managing water, again, super important. That's why we've thrown it in the location module and invested some of our R&D efforts there. So really, you know, by putting them inside the location module, we're helping to address, I'm going to say, two of the really core high-level drainage objectives. First, helping you to try and maintain, or at least have an awareness of the changes you've made to natural drainage patterns and allowing you to try and add structures in order to maintain them. And then secondly, helping to, you know, give awareness to helping to minimize the interception, accumulation, and redirection of water, which really is the crux of all those hazards that I showed on that previous slide. Okay, we're going to head now into the location module. Check out new version 12 hydrology tools. I should mention, if you are on support, you can totally get access to this beta today. It's available to any customer on support. Send us a note in the chat. We'll add you to the list. And then the other piece I should mention, while Matt was in the terrain module, everything that he showed you, although running version 12, is available in version 11. And with that, Matt, I'll let you talk now.
Perfect. I'm just starting out a new location file here, and I am not going to do every click. I'm just going to we're going to bring in a alignment, and we're going to just start by looking at how that alignment may interact with the surrounding terrain. And of course, this, if anyone was paying attention to what I clicked, well, it was an alignment that's tagged as bad road. So it's not a nice, pleasant spot to put a road. So yeah, if we had a road that we were thinking about putting across that really, really nasty slope, well, we could design our alignment, assign whatever cross-section geometry we'd like, and then, well, we're probably going to start adding in our culverts. So I'm going to let's have a peek at this one. And we'll come in here. So if I decided I wanted to add a culvert there, I could, and I'll go to the culvert panel, which many of you will be already familiar with. And well, we can set that pipe in its to-be location. And well, in 12, we've got this hydrology calculations, and it's tagged to include. And right off the bat here, I'm going to do something that's kind of not the necessarily intent of the tool, but we're going to turn this on. I'm going to calculate my drainage area to that feature by itself. We'll notice that this warning here is that the current alignment is not included in the tin surface. We'll address that here in a moment, but we'll run this one go. And it's just telling me I've got hydro enforcement features in my topo. Do I want to use them? Yes. But these culverts are going to be hydro enforcement features as well. So we've ran it. Now, if I had it turned on, we could have seen it right away. But we'll turn on our hydrology checkbox, and we can see, well, that drainage area being calculated. Now, with this, if we wanted to produce a data table with that in it, well, we could. I'm going to keep one for our volumes, but we're going to come in here and, well, add in our report points for our culvert insertion locations. And I'm probably interested in, well, my station where I've added this pipe. And we probably want to know our diameter and our length. Now, if we have a reasonable diameter assigned, well, that's probably going to be dependent on our drainage area. So I'm going to also report the drainage area here. So I can see I've got, what does that shake out to? About 20 hectares contributing. So contributing to that point. And what does that look like in the 3D view here as well? And I'm just going to turn this on so we can see the line work. But that's my drainage area limits, and I can see the most hydraulically remote path being calculated up to the top there too. Now the kicker with this is, and kind of something that I'm pretty excited about having in location, if we were to build this road and that was the only culvert that we had placed, it's going to see a lot more water than that. So this ditch is going to act as a dam and redirect, well, the road's going to act as a dam. The ditch is going to concentrate flow. So that water that hits the road upslope here is going to run down the ditch. And instead of just capturing this little area here, we're going to capture a much larger area. And aside from, well, concentrating flow here, we're also going to rob a bunch of flow downslope of the road. So if we wanted to calculate that or account for that, well, when we click Hydrology Tools up here, we would typically be cognizant of this. So that warning is saying that we don't have our road in the surface. So it's not merged. And there's a few different spots where we could access this, but basically it all leads to this location here. And I'm going to say I want that road to be included, merged into my topo. So now, and it's telling me that my hydrology calcs are out of date, we can do a quick recalc and we'll calculate our drainage area. And with this, by merging that into the topo surface, it does take a little longer to calculate, but yeah, it's peace of mind. And there we are. So we've got something that is, well, a much more significant drainage area. So we went from, what was it, 200,000 square meters to almost 1 million. So yeah, that road redirecting flow certainly does matter. Now let's add in another culvert. And let's place this one here. So I'm just going to add it in on this bend on that convex ridge. And we'll rerun our hydrology tools. This time, let's add one more, and we're going to run flow paths with it. So there we can see, well, we have our drainage area broken up. So not just all going down there, we've got some of it coming off here. And of course, in actuality, we'd add in more than just one here. But with flow paths, we're able to see the flow from that outlet downstream and see where we're going to end up putting that extra water that's been concentrated. Let's continue right along. And aside from just flow paths, if we want to add in another, maybe we want to calculate what our, another calculation, maybe we want to calculate what our streams would do if we recalculated this with the same stream calculation that we previously used, only with the road being accounted for. We'll use the same drainage area that we used when we did it previously. We'll use a smaller cell size here. So we're going to go with a 1 meter cell size just to make it so we can actually account for our ditch and make sure we're not kind of obfuscating that with too large of a cell size for that. We'll hit OK. We'll include all three of them. And now we can see that, well, instead of just having the drainage areas calculated, that flow path calculated from our culvert outlet, we can see the streams that we are intercepting. So here we have a line that is both a line pre-road and post-road, but the pre-road stream is visible here because it's being diverted. So in my plan view, I'm using this teal color to indicate my streams calculated with the road, whereas that blue line that we used in terrain is visible elsewhere. So again, we can see that we're diverting flow, concentrating it in this direction, but we're robbing flow from downslope of our road. Now, how does that look like if we kind of speed run it through, add all our culverts, and have a better feel for what we're dealing with, and to save having to go through and add each pipe individually? I'll just pop open and this one was the one I meant to. All right, so this one, same geometry, only we have our pipes added in here. So a lot more culverts, and we can, well, run those calculations, see what we're dealing with, and come up with a more informed decision, be able to spot issues if we have any issues. Now that little warning there is just telling me that we're doing calculations for a lot of culverts, and that it may take a little longer, which is to be expected. It's fairly quick. There is a little bit more of a noticeable hit to calculation time if we have something where there's, say, several switchbacks going over top of each other and calculating how that flow is going to interact with the culverts going from one leg of the switchback to the other, to the other, to the other. We'll let this thing plug away. We're going to turn on those hydrology lines. And just to make it a little obvious here, we're going to make our flow paths red. We're going to make our drainage areas orange, and we'll leave the streams as is. And there we are. And then for this here, we can zoom in. We can see what we're actually interacting with. And that's why I'm making all sorts of misclicks. I meant to have that turned on. I was wondering why that. Yeah, so we'll calculate that. We'll rerun the hydrology tools with that merged into our surface. And we'll see that it's going to, show us what we want to see. And here it takes a little longer to merge that surface together.
This is a great opportunity to remind you guys, live webinar audience, please feel free to type your questions into that Q&A section of your GoToWebinar panel. Although we're a little bit over time, we are going to hang out and answer them after.
And there, our solution looks like it makes a lot more sense. So here the road is acting as a dam in this case. So we can look at it here. We see, well, we've got our drainage area for that specific area, but we're not getting that flow that we were getting coming down here since it hits the ditch and goes that way. We might not be inclined to put a culvert in just to have another culvert immediately after it where there's no stream. And well, we can see all across the slope that we are actually capturing all the flow that hits our road with our culverts and cross drains. And then the one exception to that is off the end of our switchback, where we aren't adding a culvert to catch it. But we are cognizant that we aren't concentrating a lot of flow here. So, and of course, if we wanted to, we could produce that data table and look at our drainage areas to each one of those culverts that we've added. So it's all about kind of getting a better feel for what we're up against and how we're interacting with the terrain. And again, kind of another tool that's coming in 12 that's nice to visualize while we can drape that plan view surface onto our topo in location in 12. Now with this, aside from adding lots of culverts, it's still one of those things that it might not be the right thing to do. We could, of course, throw lots of money at it and try to make this a more robust solution. But ultimately, we are changing the natural flow paths. We're intercepting water that, well, it's coming down upslope, putting it in a ditch, speeding it up, concentrating to given points. And I would be awfully nervous about putting more water than what we previously had at specific points along that slope. Now, that being said, there might be some spots where we're giving less, but if we take water away from one location, it does ultimately have to be redirected somewhere else. So it's, of course, nice to see how our culverts interact with the surrounding terrain, but it's not just the culverts. And, well, using the tools to find better road locations is also quite meaningful. So same slope, not quite as, well, not a nice location, but at least we're not dealing with every one of those drainage areas. As we traverse across that slope, we can kind of isolate our impact to be on a convex place and manage around it a little bit better. So once again, if we wanted to see our impact, and this time I will make sure that I've got that merged into my surface, I've got my culverts in, we can click that hydrology calculation. I'll calculate my surface here too at the same time. And once again, and here typically you wouldn't turn it on every time, you just save it with your screen layout. And there we are. We can see what we're interacting with. Down here I've got that current culvert selected for the main stream. If we click another one of these culverts, we could see, well, this guy here is only taking flow along here. We've got a little bit of flow from the upper leg of that switchback coming through that culvert. So we're golden there. That one not taking a lot of drainage area, but still just a matter of preserving those flow paths as best we can. So really easy to get an informed decision regarding how you're interacting with that natural flow regime. With that, I think I've covered what I wanted to cover. Yeah,
Awesome. We are going to transition into a couple questions that we've got here, and I'm actually going to start by addressing the first one myself, which is when you say location or in location, what does that mean? So this is a great opportunity for those of you who are newer to RoadEng to remind you that RoadEng is actually a modular program. We have the terrain module, which if you own a license of terrain tools, that's all you get, just the terrain module. And then we have RoadEng, which is comprised then of the terrain, where Matt started our webinar off today, and then location. So location is really all about corridor design. Program for that. So now, as of version 12, hydrology tools now exist in both modules. So pretty exciting update, as well as a couple of other ones Matt sprinkled in today. Again, reminder, if you're interested in the beta, just let us know. Happy to set anyone who is on support or subscription up with that. Okay, Matt, your first question, and you'll probably want to share the screen again. It says, I'm often using LiDAR data where existing bodies of water are represented by flat surfaces in the tin. Can the software still identify these locations as water bodies?
But yes, and I don't know if I have a great example in this one. Yeah, I don't think there's anything super flat. But if you have flat areas, the software will, assuming that they're enclosed by the surface, the software will calculate flow from one side to the other. So it still uses the fill depression functionality. So if those flat areas are in a depression, it'll fill it up and then find the outlet of that lake or pond or what have you. One thing to note there is that the tool is looking at the lowest outlet. So, and it is just kind of looking at it in terms of where it reaches that outlet point first. So if it was more of a flood modeling scenario where you had peak flows that were going to come up several meters and maybe multiple outlets of the lake, it won't account for that. It's going to be one outlet per body of water. If the bodies of water are on the edge of the tin, then the pour point will kind of, be along the outside edge, and it may not capture it as a pond at the click of a button, but you could just calculate the contour and yeah, show it as being a blue line if you like as well. So yeah, pretty easy to run with the flat surfaces and the LiDAR data. And then for those of you that may have LiDAR data that the bodies of water are not perfectly flat, depending on how they're processed as well. The fill depression depth functionality here does do a good job of smoothing that out and yeah, highlighting where the flat areas are likely water, or flatter areas are likely water by capturing them as ponds. Yeah.
Awesome. Okay. 12 o'clock. I'm going to tackle the last two questions as well. Let's turn my camera on to say goodbye to everyone. So this question is the hydro enforcement checkbox available in Terrain Tools 11, or is that a new feature in 12? So in version 11, you can absolutely leverage hydro enforcement features inside of the terrain module. And that kind of connects directly to the other question, which is, I'm using version 11. Do I still have access to the hydrology tools in location, or are those only in 12? So in 11, terrain's got the tools in it. In 12, we're adding them to the location module. So for that question asker, not available in 11, but if you want to join the 12 beta, you can install both versions side by side, very much like Matt did today. With that, guys, thank you so much for coming. We hope you found our content useful. There will be a follow-up email. The video is going to be on YouTube, and love having you here. We'll see you again in another webinar. Thanks everybody.
Everyone.